Part 1 Basics. Problem 1. Input a positive integer n. Calculate the sum s, n, using the following formula. Problem 2. Input a positive integer n. Calculate the product s, n, using the following formula. Problem 3. Input a positive integer n. Calculate the sum s, n, equals. Problem 4. Input a positive integer n. Output all even numbers in the range from 1 to n. Problem 5. Input a positive integer n. List all divisors of the positive integer n. Problem 6. Input a positive integer n. Calculate the sum of all divisors of the positive integer n. Problem 7. Input a positive integer n. Output the digits of the positive integer n. Hint: use the modulo operator and integer division by 10. Problem 8. Input a positive integer n. Find the largest digit of the positive integer n. Problem 9. Input a positive integer n. Write a program to check if n is a palindrome or not. A number n is a palindrome if it reads the same from left to right or from right to left. Part 2. Advanced. Problem 10. Input a positive integer n. Write a program to extract the digit at a certain position k of n, counting from right to left. Problem 11. Input a positive integer n. Write a program to check if the positive integer n is an Armstrong number. An Armstrong number is a number such that the sum of the kth powers, where k is the number of digits of n, of its digits is equal to the number itself. Problem 12. Input a positive integer n. Write a program to check if n is a prime number. A prime number is a number that is only divisible by 1 and itself. Problem 13. Input a positive integer n. Write a program to find all prime numbers less than a given positive integer n. Problem 14. The Fibonacci sequence is a sequence of numbers where each number is the sum of the two preceding ones. The Fibonacci sequence starts with two numbers f0 and f1. The initial values of f0 and f1 can be 0, 1 or 1, 1 respectively. The formula for the Fibonacci sequence is as follows. The Fibonacci sequence is as follows. Enter a non-negative integer n. Calculate fn. Part 3. Logical Reasoning. Problem 15. Describe the operation of an ATM machine. The ATM machine contains 4 types of banknotes: 500, 200, 100, and 50. Each type of banknote corresponds to a given number of banknotes. Count 500, count 200, count 100, and count 50. Assume the ATM machine contains an initial default amount of money x. 1. Write a program to simulate the operation of an ATM machine with the function allowing the user to enter the amount of money to withdraw, n. 2. The user can choose to perform the withdrawal function until the machine runs out of money or end the program after completing the operation. Note: the number of banknotes withdrawn must be the minimum possible. 3. Enhance security for customers by initially providing them with a default password consisting of a maximum of 8 digits. Customers will only be allowed to access ATM functions after entering the correct password. Additional part. Problem 16. Write a program to solve a quadratic equation of the form